So let's go on to aggregation of resources now, undiscovered volumes. Okay? The table's slightly different because I've added, like I should do, the chance of success to the end. So I've got 4 prospects now, they're called, rather than fields. The volumes are kept the same, but I've introduced a 10% chance of success. So there's a couple of areas of interest there. If each of them was 10% chance of success, what does that tell me about the chance of success of my drilling program if I'm going to drill all 4 wells? That'd be quite a useful number to have, wouldn't it? Okay? It's not going to be the sum of the numbers. Well, it's not 40%. What about the total? Should I use the blue number, which is the arithmetic sum? Should I use the red? Well, this particular case, I say actually neither of them are right now. Let me try and explain why none of them work. Because there's actually something more to go. And let me explain. So let's take you through 2 slides to explain the logic. You might not understand the theory, but hopefully you can see where most companies are wrong. Most companies would do that. So they'd say maybe we wouldn't add them mathematically, but they'll quote this huge number. And how many people have seen a press release on potentially, or the prospective resource of a company with billions of barrels? It happens all the time. Okay? What they've done is they just simply assumed that all of their prospects were fields and then added them all up. Okay? So what have they just told you? Well, in the event that every single exploration well that I have on my books is successful, this will be the total. So what's the probability of that occurring? Absolutely near as 0 as you can get. So that's just a headline number. Okay? That doesn't really help the investor at all. That'd be like me saying, well, actually, I haven't just entered the UK lottery. I've been in the Euro Millions, and I'm in the Spanish lottery and the Italian lottery. I'm going to win all of them this weekend, and look at my prize fund, okay? So that's how crazy that number is, yeah? So what are we going to do? Well, let's have a look at why that would be the wrong thing to do, because we can't drop the chance of success out of that aggregation. Let's go back to our probability tree, as we call it. It's called a tree because when you draw more and more of them on, it looks like branches of a tree. There's my single prospect. It's got 2 outcomes, success and failure. 10% success, 90% chance of failure. If I'm successful, there's my diagram that shows me what I might expect to find. I've extracted the numbers. It's somewhere between 20 and 400. There's my P90, P50, P10, and it's got a mean of 100. Okay? That's quite easy. So if it's failure, it's 0. If it's successful, it could be anywhere between 20 and 400 with a mean of so 20 to 400 with a mean of 100. That's easy to understand. And most people are quite happy with a single prospect. Let's assume now we're drilling 2 prospects, one after another, which is not unusual. You don't normally just drill 1 well. So now the first probability node is the same as before. There's a 10% chance of success for the first well, or it's a 90% chance of failure. If it's successful, I find the volume of oil that we've talked about. I can drill the second well in 2 cases. The first well is a success, and I drill the second well after the first well has been successful. The first well was a failure. I will still drill a second well, okay? Just assuming I'm going to do both, regardless of the result of the first well, which is quite normal. It sets up effectively 4 outcomes of my 2 well drilling program, okay? The best outcome would be both worked, okay? But equally well, maybe the first well worked, the second well was dry, which was the second chart. Or the first well was dry, but the second well worked. Or, unfortunately, we could have actually where both of them failed. If both of them worked, then obviously what we'd find is not 20 to 400, but actually 40 to 800. Okay, so that's showing me what I might find if both of them worked. So that's both of them working. But the next 2 outcomes, only one field has worked, one of them has been dry. In which case, both outcomes there are 20 to 400. So that if I was then to say, well, let's just add up all the fields and ignore the risk, I'm actually telling you what's going to happen if only the one outcome. I'm only telling you about the total success path. I'm not telling you what happens if some of the wells are dry. You can see in the red numbers, I've blown them up so you can actually see them. You can calculate the relative probability of each event occurring. So there's only 1% chance, in this case, that both of the wells work. Well, actually, it's maths as simple as 10% times 10%. There's actually a 9% chance of well 2 working and a 9% chance of well 1 working. So in total, actually, there's 9, 9, and 1. There's a 19% chance that at least one of the wells will work. Okay? So that's probably a bit more important number. If you drill 2 wells, each of them have got 10% chance of success. The chance of 1 well working, if you drill 2 one after another, is now 19%. By simple subtraction, then the chance of drilling 2 dry wells is 1 minus that at 81%. Okay? So beginning to get the idea. Now, if we start building and say a 4 well drilling program, and I can't obviously on the screen draw all the little charts, but you end up with 4 wells, you end up with 16 possible outcomes. From all successful, which is effectively the top of that diagram, to the possibility that all 4 were dry. Okay? And then in between there is any combination of successes between 3 wells, 2 wells, or 1 well. Okay? That's every permutation you could think of. The chance of total failures is actually 65%. We can calculate that. Right? So there's by default, the chance of finding something must be 1 minus that. That's 34%. So my chance is getting better, actually, of the more wells I drill.